and good day, geometry. We're starting our second geometric unit, which, as I prefaced earlier, is basically designed to teach you how to form a logical argument. Keyword on logical. Okay, we'll be looking at mathematical evidence in the context of theorems and postulates and properties and definitions. There's going to be a lot of writing. But there's a lot of stuff that we'll be using in future units coming at you here. So what we're going to start with is defining a conjecture. Anyone know what a conjecture is? I'll tell you, make these every single day. Okay? A conjecture is an unproven statement based on observations. Okay? An unproven statement based on observations. You look up in the morning, you see the sun outside, say, it's going to be warm out. Then you remember it's the middle of January, and say, oh, no, it's going to be cold out. Okay? But it's an unproven statement based on what you see. Right? Based on what you see. Inductive reasoning. Anyone know what this is? Inductive? There's inductive and there's deductive.
Oh, wait.
Inductive reasoning.
Sometimes it's from big or general to specific and specific to general.
Kind of. Which one is inductive?
Inductive is specific to general.
Okay, so in the context we're going to be using it in, it's inductive reasoning is conclusions. Oops. Hope I spelled that right. Conclusions based on patterns or past experiences. Okay, conclusions based on patterns or past experiences. Inductive reasoning, conclusions based on patterns or past experiences. If you go see a movie at a theater and the chair was squeaky, the floor was sticky, the sound was off, you just didn't have a good experience, you're probably not going to go back to that theater again, right? You're using inductive reasoning to make a conclusion based on something you experienced. Someone else that went to the same theater might have loved it. They love sticky floors. I don't know, right? But it's a very informal. It's a very informal type of reasoning. You do not want to go into a courtroom and state your case for or against your client based on inductive reasoning. Okay?
Why not?
Because it's not very formal.
But that's okay.
Okay. You can cross off lawyer as your list of future aspirations. Okay. Counterexample is a specific example that proves a conjecture is false. A specific example that proves a conjecture is false. All prime numbers are odd. Based on my experience, patterns, looking at primes, they're all odd. What's the counterexample? Like 2, right? 2 would be the counterexample for that statement, right? It proves the conjecture false. Okay? Question so far? My day's fine. Yours? Decent? Okay.
Joe, what's your one?
3, 2, 1, you are quiet. So we're using inductive reasoning here. It's got its time and its place, right? You use inductive reasoning a lot on the math packets, particularly with that pattern block question, on the Tetris question. Kind of things where you kind of draw in, wait, I've done this before, where have I seen this before? I know the setup of this. It's got its time and its place. So it says make a table and look for the pattern. Notice the pattern and how the number of connections increases. You can use this pattern to make a conjecture. So with 1 point, there's a picture of 1 point, and there are no connections that can be made. With 2 points, drawn and 1 connection, just connecting them straight across. With 3 points, there are 3 connections. You can connect the first one and the second one and the third one, and the first one and the third one. 3 total there. For 4 points, kind of doing some old man foil crab claw stuff going on here. There are 6 connections. How many connections can be made with 5 dots? Okay. Well, 10. And you can get that by counting, or what's the pattern that you're seeing develop here? Going from as our points increase. Joey.
It adds the previous number.
So what do you mean?
So 0 plus 1, that's 1.
Yeah.
2 plus 1 is 3. 4.
What did you do?
Other 2.
What did you show?
Plus 1 plus 2 plus 3 plus 4.
So, okay, so Joey's looking at the table vertically here. He's saying 1 plus 0 gives us this next 1. 2 plus 1 gives us the 3. 3 plus 3 gives us the 6. 4 plus 6 would give us the 10. Right? Is that where you're going?
Yeah.
Okay. Anyone else see something different? Blake?
If it's like the second one is 1, you add 2 for 1.
So kind of where I thought you were headed was the difference between 0 and 1, we're adding 1 here. From 1 to 3, we're adding 2. From 3 to 6, we're adding 3. So from 6 to the next one, we'd be adding 4. Okay? That's another pattern here. Right? That's all I have to say about that. Have any questions? I told you to give me plenty of time for this. Plenty of time. Counter examples. If the product of 2 numbers is positive, then the 2 numbers must both be positive. What is a counterexample to that statement? If the product of 2 numbers is positive, then the 2 numbers must both be positive. Drew?
A negative times a negative.
Negative 2 times negative 3 is a positive product. Positive 6. That would be a counterexample. Right? If the product of 2 numbers is even, then the 2 numbers must both be even. If the product of 2 numbers is even, then the 2 numbers must both be even. What is the counterexample to that? Drake?
3 times 4.
3 times 4. Right? Even product, 1 odd, 1 even number. Okay, so just something that, you folks love to prove me wrong. You love to prove each other wrong. They're counterexamples. Okay. Now, when you are arguing, and I expect to hear, well, here's a counterexample.
You prove them right.
Okay. Here's why your conjecture is false. Right. I want to hear these pieces of language.
That
Like,
ruined it.
Do you think 0 is even or not?
neither. I mean, it's in the even position. So I suppose if I had to pick one, I'd say even. But no. Last one, real world. What is a common example of you using inductive reasoning to make a conjecture? Essentially, what this is asking is, when do you use informal reasoning patterns, experiences, this kind of judgments to make a conclusion? I said whether earlier, right? Raise your hand, please. Okay. What are other examples where informal reasoning is used where you've done this? Yes. Drake, you have your hand up?
Kind of goes along with like weather, like past experience of like the sun being warm. You
Yes.
think it'd be warm,
I've heard it's warm.
but it's the middle of winter. Like
Right. So a conjecture to it's warm when it's sunny out would be, well, what about when it's negative 25 degrees in the middle of January, right? The sun's still shining, still cold. Caleb.
Vegas' odds on sports.
Vegas' odds on sports. Tell me more about that.
Also, like if you, on past experiences of watching a team play good, we'll say good football, right?
Yeah.
Pretty
Then,
much the
and they
Vikings.
give them the odds to win the Super Bowl, but then
Not the pattern.
Okay, so the way that Vegas determines odds is based on past performances and experiences. Is that what you're saying? I like that. There's also I would be careful to call that straight inductive reasoning because there's a lot of mathematical stuff that goes behind it as well. But I see where you're coming from, and I will agree with that. The past experiences does play into that sort of thing. Not that I would know how odds in Vegas work, but you're trying to pay for 4 kids now. Maggie.
If you in Vegas, can you bet on teams losing?
I wouldn't know anything about that.
So I could just bet the Packers seasons and I'd be a millionaire.
You wouldn't because they're 8-3.
Yeah.
Blake.
Boy.
They're all in
Hand
the
up.
playoffs.
No.
Let the
You bet on ties?
Bet on
Let
ties.
me
Mostly.
Yes. Soccer lines.
The Vikings.
Okay, how do we get that? Look what you've done. Okay, back to inductive reasoning, conjectures, informal reasoning. When you make these are oftentimes like snap decisions, right? You walk into a room, you see something going on, you make a conclusion, right? You do this whenever you meet someone new. As much as we want to say, don't judge a book by its cover, first impressions, right? When you make a first impression on someone, they're making their decision about you informally. You walk into a room in a job interview, if you're looking sharp, you got good posture, okay, your eye contact, you're articulate, you're going to make a better impression. Even though they know nothing about you, about your hobbies, about your kindness, just that first impression, that's why they matter. People do this all the time. What are other examples? Okay. When you walked in today, you saw me wearing a hat. How many of you guessed it was because I was supposed to be wearing Helga horns? Oh, William. Okay. You probably came up with your own idea. Ooh, bad hair day? No. He burned his head? I don't know. Right? But you make decisions.
Finally lost.
He lost all of his
Curling
hair,
iron.
right?
I got a bowl cut. Just kept this part here. Yes.
Hat hair.
Blake.
Your video game, the guy keeps doing the exact same thing.
What's that? Sorry?
Nothing.
Video game is all I heard.
The guy keeps doing the exact same thing over and over.
What video game are we talking about?
Any video game.
The guy keeps doing the same exact thing.
Among
Fortnite.
Okay.
Alright, we just jumped.
All right.
I'll bet that I'll be
Your homework then.
We're not
going
to
play my
What?
conjecture game. You are to do on page 75. I want you to do number 5 through 12, comma,
13, 14, 15,
No, Miss Joseph convinced me
16,
otherwise.
17, 18.
12
we
through
can do some
14.
counter
This is kind of
examples.
fun.
13 through 14.
Yeah, let's do 14 through 17 also.
Instant feedback. Look at this. I love it.
14 through 17. And then
Oh, no, you're done, you're
From
done.
page 80.
33.
Oh my God.
We never really talk in Mr. Olson's class, so he likes when it's really loud in here.
And because y'all are who you are, you have to show your work.
No.
Now you can't say,
How do you show your work?
I didn't. I don't know, but you have to do it.
Just show the answer.
Okay.
Just show
Questions,
your
comments,
No,
concerns?
that's ridiculous.
Leave it in the comment section below.
All right, that's my math, folks.
So